Consider a rigid body, and rigid bodies don't deform but retain their shape under applied forces. And if this rigid body is connected to a hinge, then the force of weight acting through its center of mass is going to produce a torque that's going to cause it to rotate. And this hinge is like a door hinge, so it stops the rigid body from translating, and therefore it's going to have a reaction that's equal to the force of weight. So force equilibrium is satisfied, but here rotational equilibrium is not satisfied. So the sum of torques is not zero. So therefore, to put this rigid body in rotational equilibrium, you'd put it on some surface to support it at one side, and therefore this here would produce a reaction force that acts upwards. So we'll call that the right hand force, and this produces a torque about the hinge that opposes the torque due to the force of weight, to put that rigid body in rotational equilibrium. And therefore, if you have a reaction force on the right, then the reaction force on the left is going to be smaller to keep that rigid body in force equilibrium.